Hello everyone, this is Math 6. Welcome to lesson 7-7. Find surface areas of pyramids. In this lesson, we'll be able to draw a net of pyramid and use it to find the pyramid surface area. So last lesson, we used the net to figure out surface areas for the prisms. This lesson, we'll be able to draw nets for pyramids. Let's see what's the difference. Look at, solve, and discuss it. The fence in Marcy's front yard has decorative tops in the shape of square pyramids every 6 feet. Marcy paints each base of each top a different color before attaching the tops to the fence. What is the total surface area that she paints on each decorative top? So basically, we need to find the surface area of this top. It's a prism. No, it's a pyramid, right? So what tools can you use to help solve this problem? Let's try to figure out if we could draw a net for this. So you have a base over here, right? But we just want the decorative top, like over here. We're not going to count the base. Oh, before attaching the tops. So she'll probably paint the base as well. So we're just finding the surface area for all the areas we can see. Okay, so this could be the net of this pyramid when it's flat. Okay, I'm just going to cut, we're going to cut the edges over here and lay it flat on the ground. That means where's 4 inches? On the squares, right? 4 inches, 4 inches. Okay, and then the height is going to be 7 inches. So figure out the area of the base. 4 by 4 is 16 inches squared. What about area of a triangle over here? 4 times 7 divided by 2 is 28 divided by 2. So that's 14 inches squared. Okay, so you're gonna multiply that by 4 so that you have the area of all the triangles. And then you're gonna add them all up. Okay, so surface area will be 16 inches plus 14 plus 14 plus 14 plus 14, right? 4 of them. And that's going to be 72 inches squared total. So Marcy needs to paint 72 inches squared. Or let's just write it. She needs to paint 72 inches square for each decorative top. Okay. All right, let's look at math practices. Use structure. Suppose the side lengths of the square base of each decorative top are increased by 2 inches. What is the total surface area of each top? So I guess the triangles stay the same, like the height, but your bases of the triangles will also be different, right? So then you have the same net, but then your square is bigger now. So instead of 4 inches, it increased by 2. So 4 plus 2 is 6. So 6 inches. But then the height of the triangle stays the same. That's still gonna be 7 inches. So you're just gonna have 6 by 6 as base. So 36 inches square for the base. Plus the area of the triangles would be 6 times 7 divided by 2. 6 times 7 is 42 divided by 2 is 21, okay? So 21 inches square times 4, which is equal to 84 inches square. And so if you add them all up, 84 plus 36 would be 120 inches square. Okay. All right, so solving surface areas of a pyramid is very similar to solving surface area for prisms. I think it's just less steps too, right? You just need to get the area of the base and then the sides. So let's look at the next page. Think about how we can use, how we can find surface area of a pyramid. Example 1, find the surface area of a square pyramid. Maxwell made a model of a house using a cube for the bottom and a square pyramid for the top. He wants to paint the top of the house blue to match the bottom of the house. He already painted the cube. 1 tube of craft paint covers about 20 square inches. How many tubes of paint does Maxwell need to cover all the faces of the top of this model? So notice that you don't just figure out the surface area, you need to figure out how many paints you need. So 1 paint covers 20 square inches, okay? So after you figure out the surface area, you're gonna divide it by 20 in order to figure out how many tubes of paint you need, okay? So look at the pyramid. Because the base of this pyramid is a square, the triangular faces are also identical because they're all gonna have the same base and height. Okay, so looking at your net, you can figure out the area of the base. 3 times 3 is 9 inches square. And 3 times 5 divided by 2 is the area of 1 triangular face. And that's 7.5 inches square. Times that by 4 and add your area of the base and you get 39 inches square. So that means how many tubes does he need? 1 tube of paint will cover 20 inches square. So if he has two tubes of paint, he'll cover 40 inches square, which means it's going to cover 39 inches square. So he just needs 2 tubes of craft paint. Okay, you can also use it using the surface area formula for the pyramid. If you do not want to draw the net every time, you can use the surface area formula for the pyramid. But notice it's not the same formula for prism. For the prism, it's much longer, right? But the area of the pyramid, you just need the area of the base. That B, capital B represents the area of the base. And then you add the number of the product of number of faces times the area of each triangular face. Okay. All right, let's look at the triad. See if you can find the surface area of this square pyramid by yourself. Make sure you draw a net because the question tells you to draw a net and figure out the answer. Come back when you're ready for answers. All right, are you ready? All right, your net could be a square with 6 centimeters on the side, on each side. And then your triangular bases are gonna be all identical with a height of 8 centimeters. Okay, label your dimensions. So your area would be the area of the base, 6 times 6 plus 4 times, because you have 4 triangular faces, 4 times 1/2 of 6 times 8. That is the area of the triangle, right? So you have 36 plus 8 times 6, 48 divided by 2 is 24. So 4 times 24, right? And that's gonna be 36 plus 106. Wait, 96. 36 plus 96 is going to be 132 centimeters square. Okay, that's the surface area of this pyramid. So let's look at convince me. For the pyramid in the triad, what values would you use for B, capital B, that's the base, the area of the base, and how many number of faces do you have in A in the formula of the surface area? So the area of the base is 36 centimeters square centimeter, right? And then N, how many faces do you have? 4. And then the area of each faces on the sides, the triangular faces, are going to be 24. Okay, we already used that. So label them down. Okay, let's look at the next page. Example 2. Find the surface area of a triangular pyramid. Tamara made a small gift box that has the shape of a triangular pyramid. The faces of the box are identical equilateral triangles. How many square centimeters of cardboard did Tamara use for the box? So first, you can draw a net having a triangular base and then triangular sides. The faces of the triangular pyramid are 4 identical equilateral triangles. So if you draw a net, it's gonna be one large triangle. And then you're gonna find the area of each equilateral triangle and then find the surface area as a whole by multiplying that by 4. Okay, and that's your answer. So see if you can do triad. This one. The faces are equilateral triangles and there are 4 identical faces. They just want to make sure that you know them. So you find the area of one triangle and then multiply that by 4. So draw the area, find the area T of each equilateral triangle. A triangle is base times height divided by 2. So what's base? 4. Height is 3.5. So 4 times 3.5 divided by 2 is 14 divided by 2, which is 7. The area of each equilateral triangle is 7 meters. Okay. Find the surface area of the triangular pyramid. So the surface area of this whole thing is this area of one triangle side, one triangular base times 4 because they're all 4 identical faces. So 4 times the area of one triangle is going to be 4 times 7. And 4 times 7 is 28. So the surface area of the triangular pyramid is 28 meters square. Awesome. So that was our lesson 7. You can use the net or you can use the equation for the pyramid to figure out the surface area of the pyramid. All right, guys, that was lesson 7, finding surface area of the pyramids. We'll continue with finding volume with fractional edge length in the next lesson, and that is our last lesson. I'll see you guys in the last video. Bye.